the number up into fours, right? A binary number digit into fours, and then solving to get the hex, converting from binary to hex. But we're gonna continue with that. As soon as the stream comes up, we'll get started. Okay. All right.
It's live.
Is that? All right. So now, let's look at our hex. This is where we stopped the last time, right? If you look at this chart, it gives you decimal numbers, 0 to 15, because hex goes from what? 0 to 15, which is how many digits? How many?
16.
16, right? So, the hex of values is 0 through 9, and then A through F. If I wrote a number, and I wrote A, B, C, D, E, F, G, base 16, is that correct?
No.
Huh?
No.
What makes it incorrect?
A G.
The G. G is not a valid digit. But if I were to write, I know my board probably will work. If I were to write this, is that valid?
What does that say?
BAD, base 16.
Yeah.
Huh? That's valid. B is valid, A is valid, D is valid, D is
And
valid.
it has to be capitalized, correct?
Huh? Not necessarily. Alright? So, now, if you look at the far right of that table, kind of like with our octal, we had what? Our 3 columns. Now we're going to have 4 columns, where when we're going to be converting a number from binary to hex, each digit going to have to be represented by what? 4 binary digits. Whereas when we converted an octal number to binary, we only did what? 3. Now when we did the 3, how many columns we had to deal with? 8 to the 0, 8 to the first, 8 squared, right?
Yep.
So if we had a number, the largest number that can fit binary, that's equal to what? Huh? 7. Because what? 2 to the 8 is 1. Not 8, my fault. This should be squared. I mean 2. 2. 1, 2, and 4. So 4 plus 2 plus 1, which is what? 7. That's my fault. I went base 8. Now, so if we're dealing with hex, all we're doing is adding an additional column. 2 to the 3rd, which is what? 2 to the 3rd is what?
8.
8, right? So the largest value is what? Goes from 7 to what? Huh?
15.
Huh?
15.
How many?
Let's see, 12, 13, 14, 15.
All right, so we got our 15, right? So this is where we get that from. You got what I'm saying? So now, given that, let's look at the process of converting a binary number to, well, this first one, we want to convert hex to a binary. What you do is, for every hex value or digit that you have, you're going to do what? For every digit, I'm going to represent it by 4 what?
4.
Binary digits. Right?
Yeah.
So, A, the value of A is really equal to what?
10, 0,
10, right? So, and if you wanted to actually find out how that's done, 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 8, 4, 2, 1, right? All right, so now, how can I get 10 in these four, the sum of 10 in these four columns by using just ones and zeros? 8 plus 2 equals 10, right? So, this would be 1, 0, 1, 0. C is what?
12.
12. So this is 10. How would I get 12?
1100.
Huh?
1100.
You got me? 4, 8 plus 4, right? So this C would be represented 1, 1, 0, 0. Now F is what?
15.
Which would be represented how?
All 1, 1, 1, 1.
Right, so 1, 1, 1, 1. And this is what? Binary. So ACF in base 16 is equal to this value in base 2.
Pretty much the same thing as.
Same thing, but like he's dealing with 4 binary digits rather than 2. Alright? Now, the reverse, if you wanted to convert a binary digit, right?
I got 4 columns, right?
Correct. So give me some ones and zeros.
1, 0, 1, 1, 0, 0, 1.
That? Alright. So, and this is binary. If I wanted to convert that to octal, no, and I'm just breaking away. Octal, what I do?
Break it up 3.
In 3. Here, I break it up here, and break it up here. Right? What would I get?
1, that's 3.
Right? As if I wanted to convert it to octal. If I want to convert it to hex, the same number, I have to break it up in what?
4.
4. Here. Oh, I don't have one? Put a 0. So now, 1, 0, 0, 1 is equal to what? 9. And, I'm going to put an 8 here. And 0, 1, 0, 1 is equal to what?
5.
So, 1, 0, 1, 1, 0, 0, 1 in base 2 is equal to 131 in base 8 or 59 in base 16. Everybody see that? Everybody got that? Yes, ma'am.
And we're just using the first 4 from the right to left.
Right, because we're doing the 4 digits, and those 4 represent 16, or the 15, the value 15. 8 plus 4 plus 2 plus 1, right? Okay? Now, if we wanted to take this 59 in base 16 and convert it to decimal, what we'd have to do?
Can you repeat that?
If I wanted to take 59 in base 16 and convert it to base 10. Remember, anytime we convert to base 10, we gotta have to multiply. Remember? We in base 16, so we gotta go into the 16 table, all right? Placement table. And how many digits we have? Just 2, right? So 16 to the 0 is 1. 16 to the 1 is 16, right? Right? So I got 59. 9 times 1 is what?
9.
Plus 16 times 5 is what? It's 0. 80, right? So 89 in base 10. You see what we did? Took this hex number, placed it under the hex table, and then multiplied the columns. Right? And like I say, that's kind of like doing what? If this number was 59 in base 10. Well, no, let's just take 89. 89 in base 10 is 9 times what? 1 plus 8 times 10. 10 to the 0 is 1, 10 to the first is 10. And if you went on, 10 squared is 100. So the next column would be the hundreds column. Right? Any questions? No questions. All right. Got a few minutes of class, right? Now, what I'm gonna do, I'm gonna post this quiz we've just taken, so you can take it. And I'll post this large quiz. It's a larger quiz that's gonna contain hex, hexadecimal to binary, binary to hex, octal to binary, binary to octal. Okay? Yes, ma'am.
How many attempts will we have for that?
But you're gonna do that at your leisure.
Is that
Okay?
timed or is it,
Hmm?
is that one time?
I think I do it because I don't want you just going in there and finding resources and doing.
Just type into an online converter or something like that.
Right.
Damn.
But I'm gonna tell you, all they're gonna do is hurt you.
Yeah.
Because you won't learn how to do it. You got me? All right?